Liquid-liquid mixtures. There are two types of liquid-liquid mixtures, namely immiscible and miscible liquids. Immiscible liquids do not mix but form distinct layers. Examples of immiscible liquids are vegetable oil and water, kerosene and water. Miscible liquids mix to form a homogeneous mixture. Examples of miscible liquids are water and ethanol, water and milk. To understand how immiscible liquids can be separated, we will observe a few experiments. Experiment. How immiscible liquids are separated. In this experiment, a mixture of colored water and kerosene is put in a separating funnel as shown in the setup. The mixture is allowed to stand for a while. The tap of the separating funnel is opened and the bottom layer is allowed to flow into the beaker. The interface is discarded, leaving the top layer in the separating funnel. A mixture of water and kerosene is immiscible. The water is colored to distinguish it from kerosene. Kerosene floats on water because it's lighter. The interface contains water and kerosene. It is discarded because it is not easy to separate the two liquids at the interface. Immiscible liquids are separated by the use of a separating funnel. Decantation can be also used to separate immiscible liquids, but is not efficient. A dropper can also be used to separate immiscible liquids by sucking the upper layer. The dropper is used to suck one layer, transferring it to another beaker repeatedly. This method too is not accurate. Separating miscible liquids. We have already learned that miscible liquids are liquids that mix to form a homogeneous mixture. To understand how these mixtures can be separated, we shall observe these experiments. Experiment. How to separate a mixture of water and ethanol. In this experiment, a mixture of ethanol and water is put in a round-bottomed flask as shown in the setup. The mixture is heated gently as temperature changes are noted. The distillate is collected in the conical flask. Water and ethanol are miscible liquids. They are separated because they have different boiling points. Pure ethanol boils at 78.2 degrees Celsius, while pure water boils at 100 degrees Celsius at sea level. When the mixture is heated, ethanol boils off first at about 78 degrees Celsius, and is collected as the first fraction of the mixture. The temperature remains fairly constant until the ethanol distills off. At this stage, the temperature starts rising and the distillate collected thereafter is mainly water as a second fraction. This process of separation is called fractional distillation. The purpose of the fractionating column is to allow water vapor to condense into liquid and flow back into the flask before the boiling point of water is reached. The glass beads increase the surface area for condensation. Fractional distillation is used to separate miscible liquids that have different but close boiling points. A Liebig condenser uses the counterflow principle to cool the vapor efficiently. If the inlet and outlet were exchanged in the Liebig condenser, condensation would still occur but less efficiently. This process of distillation has several applications. For instance, distillation of crude oil to obtain fractions such as diesel, petroleum and cooking gas. Recycling of used oil. Extraction of liquid air in the manufacture of nitrogen and oxygen. Experiment. How oil is extracted from nuts and seeds. Let us observe this experiment to learn how oil can be extracted from nuts and seeds. In this experiment, groundnut seeds are crushed in a mortar using a pestle. The crushing is done while adding propanone a little at a time. The resulting solution is decanted into an evaporating basin. The solution is left in the sun for some time. Cashew nuts, coconuts, castor oil seeds, sunflower seeds and cotton seeds can also be used. Nuts and seeds contain oil which is useful. The oil can be extracted using a suitable solvent such as propanone. Propanone, also known as acetone, is a liquid that is often used as a solvent in various industries. The nuts are first crushed to increase the surface in contact with the solvent. Water, a common solvent, cannot be used in this extraction because it will not dissolve oil. Once the oil has dissolved in the propanone, the solution is left in the sun for the solvent to evaporate. The oil having a higher boiling point than the solvent is left in the evaporating dish. This method of extraction is known as solvent extraction. When a drop of the residue liquid is put on a piece of paper and held against light, a translucent patch is left on the paper. Oils leave a translucent patch on paper. This can be used as simple tests for their presence. Oil obtained this way can be made more pure by washing the product in water and separated from the water using a separating funnel. This method has several applications, e.g. extraction of oil from nuts and seeds, extraction of natural dyes from plants, extraction of some herbal medicines from plants, extraction of caffeine from tea and coffee. It can also be used in dry cleaning to remove dirt. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.